Mechanics is a science concerned with the motion of bodies under the action of forces, including the special case in which a body remains at rest. Of first concern in the problem of motion are the forces that bodies exert on one another. This leads to the study of such topics as gravity, electricity, and magnetism according to the nature of the forces involved. Given the forces, one can seek the manner in which bodies move under the action of forces. This is the subject matter of mechanics proper. Mechanics can be divided into three branches: statics, which deals with forces acting on a body at rest; kinematics, which describes the possible motions of a body or system of bodies; and kinetics, which attempts to explain or predict the motion that will occur in a given situation. The science of mechanics is a broad area, as can be demonstrated in the definition above. It dominates much of what will be covered in this course. As such, it is necessary to break the chapters of our book devoted to it into several modules before extending on to other topics that are covered this semester. Module 1 consists of chapters 1 through 4. Chapter 1 addresses those items expressed in one of the competencies of this course. Use and interpret SI units. SI units are also referred to as the metric system. It is used throughout the world except in the United States and has advantages over the system we use here. Unit conversions within the metric system and between the metric system and our system are something that will be done throughout this text, and getting comfortable doing so begins with this chapter. One will also find demonstrations of things like significant digits and scientific notation. Chapter 2 addresses the competency: solve problems involving linear, circular, rotational, and vibrational motion. Specifically, linear motion will be covered. Definitions of different terms used to describe motion will be introduced, such as displacement, distance, speed, velocity, and acceleration. Graphing of these terms against time will also be introduced. Graphs will not only be important in this chapter but others, but also in the labs performed as part of this course. A second competency of this course, which will have much broader application throughout this text, would be synthesize applied physics concept to solve contextual problems. With the addition of scientific equations to solve problems, it becomes necessary to develop in your mind a system of steps that will allow you to go from the wording of a problem to the choosing of one or more equations that may get you to a solution. The problems introduced in this chapter begin your journey in problem solving, which you will apply and modify as different types of physics concepts are introduced. Part of this process will also cover another of the competencies of this course: distinguish between accuracy and precision of measurements. When punching numbers into a calculator and coming to a final answer, it is necessary to look at those values that went into the calculation and let them determine how many decimal places, for example, one should keep in a final answer. In many cases, one decimal place will do. This process is known as significant figures and will come into play in labs that are done. Chapter 3 continues covering this competency with the introduction of two-dimensional motion. In many cases, such motion can be broken down into two different motions, one in the vertical, one in the horizontal. In doing so, the concepts introduced in Chapter 2 can be applied to solving problems of this type of motion as well. Newton's laws of motion are three fundamental laws of classical physics. The first states that a body continues in a state of rest or uniform motion in a straight line unless acted on by an external force. The second states that the net force acting on an object is proportional to the acceleration of that object. The third states that if one body exerts a force on another, there is an equal and opposite force or reaction exerted by the second body on the first. Chapter 4 addresses these and other forces in general, allowing us to cover the competency: solve equilibrium force problems. By identifying the forces, the pushes or pulls an object experiences, we learn more about the motion the object is undergoing or not going, as the case may be. These general expressions can be used to construct equations describing the interactions of forces on an object that may either lead to an equilibrium situation, in which the object is not moving or is moving at a constant velocity, or can lead to an object undergoing acceleration, which can mean it is speeding up, slowing down, or traveling along a closed path at constant speed. So Module 1 is an introduction to mechanics, looking at the motions of bodies and the forces responsible for those motions. Several of the course competencies are addressed in the chapters making up this module. Problem-solving techniques that you developed while working problems in this module will be expanded in the future modules of this course.